Today, I will demonstrate how to conduct an ANCOVA and SPSS to determine whether math test scores differ among three teachers, Smith, Jones, and Brown, after controlling for periods missed. The dependent variable is test score, the independent variable is class or teacher, and the covariate is periods missed. So when we look at this data set, our research question is, after controlling for periods missed, is there a significant difference in math test scores among the three teachers? Our null hypothesis is that there is no significant difference in math scores among the three teachers after controlling for periods missed. Of course, our alternative hypothesis is that there is a significant difference in math scores among the three teachers after controlling for periods missed. So the first thing we want to do is check our assumptions. We need to check our assumptions for homogeneity of variance as well as homogeneity of regression slopes. So to do that, we are going to go into Analyze. Let's make sure this shows up. Analyze, General Linear Model, and Univariate. From here, we want to move our variables into their proper place. So for our dependent variable, we want to put our math test scores there and our class in with fixed factors. And periods missed is going to go down to our covariate. So now we want to select model. Now here, we want to actually build a custom term. And we'll revisit this again later. But let's bring class down there so we can add that to our model. Periods missed, so we can add that to our model as well. And then we want to go back in and select class, add that to our term by, so we can multiply or compare that to periods missed. Oh, periods missed, add that. Now add them both. So we have class periods missed and class by periods missed in our model. Click continue. Here we want to go to EM means. Make sure that we're selecting class, that factor, and putting it in the display means. We want to select compare main effects, and our confidence interval adjustment will use Boniferoni. Select that, click continue. And then last, let's select options. We want to check our homogeneity test for sure, as well as descriptive statistics. We'll leave it at that for now. Let's click continue and OK. And of course, these results aren't showing up, but let's fix that quickly. We should have both. Yay! Okay, or not. Yay, here we go. Okay, so let's talk about these results. We've got first, as we go through, as you can see, we've got all three of our teachers there, our descriptive statistics, which we will just go over briefly that our mean score for Smith is 84.10. Jones has the lowest mean score for that class at 79.93, and Brown at 80.47 in their mean class. So first, let's go ahead and check our homogeneity of variances. We do that through our Levene's test. And as we can see here with the Levene's test and looking at our dependent variable, we have an F score of 0.283 with degree of freedom of 2 and 87, and our significance value here at 0.754. So this tells us that Levene's test score here, since that is above our alpha, that Levene's test score here is non-significant, indicating that homogeneity of variance is met. So excellent. So let's do that. Now our next one we want to go to is check out our homogeneity of regression slopes. So we'll scroll down here just a little bit further and check out the text of between subject effects. Now here we want to look at that class and periods missed where they intersect and read off that line, right? So our degrees of freedom here are going to be something that's very wrong. These are not the right. Ah, there it is. Okay, losing my mind. It's been a long day. Our degrees of freedom here are 2 and under error 84 with an F value of 0.723 and a significance of 0.488. Which tells us that the covariant is not significantly related to the test score, so our homogeneity of regression slope assumption is satisfied. So it's appropriate for us to go ahead and move on to the main ANCOVA and interpret that. So let us do that, where it's going to go back up into our data here. Please go. Okay, I can't get rid of this bar. That's great. There we go. Okay. Yikes. No, 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 don't do that. Oh my goodness. Okay. Analyze. We want to click Analyze and go back into our general linear model. Again, select univariate. We still have all of our variables in their rightful place. Now this time we go to Model and we this time select Full Factorial and click Continue. Let's go check out what we have in EM means. Again, class is still there with the compare main effects and the Bonafiore method selected. Click continue. Go back under options. Here, I want to descriptive statistics. I want homogeneity tests. I also want estimate of effect size. And why not? Let's give me parameter estimates too. So we'll click continue. Click OK, and the data processes. And here we go. So for this one, what we have is we look at our mean ANCOVA results. We are going to go first over to, come on. We are going to head on over to our test of in-between subject effects. And look at our line for class. So here we've got degrees of freedom of 2 and under error 86 with an F value of 4.12, we'll round up, and a significance of, or P value of 0.020. That's telling us that since that is actually less than 0.05, that's telling us that in fact there is a statistically significant difference between the scores. So that's something we need to look into. Also tells us further, our partial eta squared here is 0.087. So we want to acknowledge that. So let's scroll on down and see what else is going on. Let's first stop here at our estimated marginal means so that we can see what's going on there. And it looks like with our courses, with our classes, got our estimated means here, and it looks like Smith has an adjusted mean of 84.10. Jones is our lowest means, once again, with an adjusted means of 79.93, and Brown with 80.47. So we see that, again, Smith is our highest our highest mean adjusted mean score, and followed by Brown, and Jones bringing in the rear at 79.93. So let's go down and scroll a little further and look at our pairwise comparisons. Let's bring that up for view. Excellent. Okay. So we can see here when we look at our first two comparisons, Smith versus Jones, and we look at their mean difference here between their class rankings or scores, we have a mean difference of 4.165 with a p-value of 0.029, which tells us that there's some significant differences there for sure. Whereas So there's that one. Then we go down to the next one and look at Smith versus Brown. Smith versus Brown has a mean difference of 3.625, but the p-value here is 0.075, which we know is not a significant difference. And then of course, we can go ahead and look. We've already looked at Jones and Smith, so let's look at Jones and Brown. And we have a negative 0.540 mean difference between those scores, but a significance or p-value of 1.000, which we also know is not at all significant. So in that case, when we look at this pairwise comparison, we see that Smith scored significantly higher than Jones's class did, and so there's where the big significant difference is, where the other ones were not significant. So I will go ahead and report my results in APA format now. And that is, an analysis of covariance, or ANCOVA, was conducted to examine differences in math test scores among 3 teachers while controlling for periods missed. Levin's test of equality of variances was not significant, with an F score of 0.037 and degrees of freedom of 2 and 87, equaling a p-value of 0.691, indicating homogeneity of variance. The homogeneity of regression slope assumption was also satisfied. After adjusting for periods missed, there was a statistically significant effect on teacher on math test scores, with an F score of 4.12 and degrees of freedom of 2 and 86, and a p-value of 0.020 and partial eta squared of 0.087. Our post hoc comparisons using Boniferoni correction indicated that students taught by Smith scored significantly higher than students taught by Jones. No other significant differences were found. And in terms of meaningfulness, although the covariate period missed wasn't significant, the teacher differences accounted for almost 9% of the variance in the students' test scores. And this tells us or suggests that institutional differences may have some impact on student performance beyond just their attendance differences. And that concludes this video. Thank you. Oh my gosh. Seriously? Oh.